Okay, so today I'm going to be going through the FP1 paper 2025 for the exam next week, right? So if you need a tutor for the exam, you can always head to tutor.com, register, sign up. If you're a tutor watching this, you can also sign up to be a tutor, make some money on the side. Expert tutors available anytime for cheap prices. So yeah, make sure to check them out. Let's get on with the paper. So for part A, your Simpson rule, we want to find a value when x equals 2. This is very simple. All we do is y equals e to the cosec squared of 2. So we just plug in our calculator. I mean, don't need any working for this. So you put e to the power 1 over sine 2 all squared. Make sure you're in radians also, because that is important. So we get 3.33. Okay, so for part B, we want to find h, which is the difference between each one. So we get h equals 0.25. And now the Simpson's rule formula, we can use it here, right? So we get integral from 2.5 to 1.5, e to the cosec squared x dx approximates to 0.25 over 3, 2.73 plus 16.31 plus 4, 2.81 plus 5.22 plus 2, 3.33. Now put that to our calculator and we'll get an answer. And we get 4.8183. We want 1 dp, so we put 4.8 to 1 dp. Okay. Now for part C, we want to find the cot x, right? So we remember our Pythagorean identities. So we have sine squared plus cos squared equals 1. Divides both sides by sine squared. We get 1 plus cot squared x equals cosec squared x. So cosec squared x minus 1 equals cot squared x. So that means integral from 2.5 to 1.5 e to the cot squared x dx equals integral 2.5, 1.5 e to the cosec squared x minus 1 dx. Using our index laws, that's a 1 over e, because you have e to cosec squared x and then e to the minus 1, which is 1 over e. So we get 1 over e integral from 1.5 to 1.5 e to the cosec squared x dx. Now from part B we found 4.8, so we have 4.8 over e. Once again, calculator, and we get 1.76. So it's 1 dp equals 1.8, and that's question 1. Okay. So question 2, we are given a differential equation. So what we want to do is find the fourth derivative. So firstly, you can either rearrange for the second derivative or just differentiate implicitly. I'm going to rearrange. I mean, this is personal preference. So we're going to get d squared y of dx squared equals 4 minus 3 dy by dx plus 2xy. And now if we differentiate both sides, we get d3y by dx cubed equals minus 3 d squared y by dx squared. Now for 2xy, we use product rule. So we differentiate x to get 1 and differentiate y to get dy by dx, and we cross them. So we get 2x dy by dx plus 2y. Okay. So now we differentiate that again, and we get d4y by dx to the 4 equals minus 3 d3y over dx cubed plus, now product rule this one. So we differentiate x, we get 1, differentiate dy by dx, we get d2y by dx squared. So we're going to get 2x d2y by dx squared plus 2 dy by dx. Differentiate y, we get 2 dy by dx. We can collect like terms and write it in the form of the question. So we put a dy by dx first. So we get 4 dy by dx plus 2x d2y by dx squared, and then minus 3 d3y by dx cubed. And that's part of the question done. So we know our values of A, B, and C. Okay. So for part B, we want to find a solution to this equation using the Taylor series expansion. Now we're given this in a question here. So all we need to do is plug in our values to find the derivatives at the point 2. Okay. So what I'm going to do is just plug in x equals 2 into this one. So we get d4y by dx to the 4 when x equals 2. That's going to be minus 3 d3y by dx cubed plus 4 d2y by dx squared, and then plus 4 dy by dx. Okay, so we know y of 2 equals 1, and then dy by dx when x equals 2 equals 1. So now we can use that into the actual equation, right? So we go to the second derivative and plug in the values. So d2y by dx squared when x equals 2, that is going to be 4 minus 3 times by 1 plus 2, 2, and then what's 1? 4 minus 3 plus 4 equals 5. So, and now we do the same thing with d3y by dx cubed when x equals 2. So we're going to get minus 3. Okay, now use the value we just got here. So we get minus 3, 5 plus 2, 1. That's the y, then plus 2 plus 4, right? Okay, so that's going to be minus 15 plus 2 plus 4 equals minus 9. So now for d4y by dx to the 4 when x equals 2, we have 4 times by 1 plus 2, 2, 5 minus 3 minus 9. And now it's going to be 4 plus 20t plus 27, which is going to be 51. So now we apply the formula we used here. We apply the formula given here. So y equals 1 plus x minus 2 plus 5 over 2 x minus 2 squared minus 3 over 2 x minus 2 cubed, and then plus 17 over 8 x minus 2 to the 4, right? If you don't know where I get this from, you just plug in the derivatives and then divide by the factorials. That's where we got it from, because if we look here, we have 5 over 2 factorial, minus 9 over 3 factorial, and 51 over 4 factorial, which is where we get these numbers from. Okay, so now for the next question, we have a inequality, right? So one thing to remember, you can't multiply by the denominator, because we don't know if it's actually kind of could here, because we know it's positive. But, okay, so what we want to do is factorize. So we get x minus 2, x plus 2, geometry squares, over modulus x minus 5, minus 4, x plus 2 is greater than 0. And then we just kind of consider cases, right? I mean, honestly, we could just leave it like this. Okay, so when x is greater than 5, so the modulus is positive, we can multiply both sides, right? So we get x minus 2, x plus 2 is greater than 4x plus 2 times by x minus 5. And now we bring everything to one side, so we get x plus 2. And now I'm going to factor out this. So we get x minus 2 minus 4x minus 5. And that's going to be greater than 0, right? So we want to simplify this. So we get x plus 2. So minus 4x plus 20. So we're going to get minus 3x plus 18, which is minus 3x minus 6. Greater than 0. So then inequality is going to be minus 3x plus 2, x minus 6, greater than 0. So now we're going to multiply everything by minus 3 to get rid of the negative. So we get x plus 2 and x minus 6 is less than 0. And our critical values are x equals minus 2 and x equals 6. Let's catch the parabola. Minus 2 and 6. We want it to be less than 0. So you got minus 2 and less than x less than 6. But remember, for this case to be true, we need x to be greater than or equal to 5. So replace this 2 value 5. So we have 5 less than or equal to x, which is less than 6. So that's the first case done, right? And now the second case is when x is less than 5. So then we'll have x minus 2, x plus 2, over 5 minus x is greater than 4x plus 2. Okay, so 5 minus x is going to be greater than 0, right? So we can just multiply both sides again. So we get x minus 2, x plus 2 is greater than 4x plus 2, 5 minus x. So that's going to tell us that x plus 2, x minus 2 minus 4, 5 minus x, doing the same thing we did in the previous part, is greater than 0. So that's going to tell us x plus 2 times by, that's going to be minus 20 plus 4x. So that's going to be 5x minus 22 is greater than 0. So that implies x plus 2, 5x minus 22 is greater than 0. So CVs are going to be x equals minus 2, x equals 20 over 5. So if we sketch a parabola, we need it to be greater. So we have x is less than minus 2, or it's 22 over 5. So we need x to be less than 5. So we have to change this to be like this. Wait. Okay. So that's going to become x less than minus 2, or 22 over 5 less than x less than 5. Because now we want to combine the cases. So we have 5 is less than equal to x less than equal to 6, and x less than greater than minus 2, no, less than minus 2, or 22 over 5 less than x less than 5. Okay, so we can combine this. 22 over 5 is like 4.4, right? So we can write this as x is less than minus 2 union 22 over 5 less than x less than 6. And that's that question done. Okay. So we move on to the next question. So for this question, we want to differentiate this, right? Twice. Okay, so for the first derivative, we should use chain rule. So we have 15 e to the 2x to the half. So dy by dx is a half 15 plus e to the 2x minus a half times by 2 e to the 2x. So that's going to be e to the 2x 15 plus e to the 2x to the minus a half. And I'll differentiate this again. We have to use product rule. So we're going to get 2e to the 2x 15 plus e to the 2x to the minus a half plus e to the 2x, bring down the power, minus a half. 15 plus e to the 2x minus 3 over 2 times by 2e to the 2x. And that is going to be 2e to the 2x divided by 15 plus e to the 2x to the half minus e to the 4x over 15 plus e to the 2x to the 3 over 2. So now we want to create a common denominator. So we get 2e to the 2x times by 15 plus e to the 2x, obviously to get the plus 1, minus e to the 4x divided by 15 plus e to the 2x to the 3 over 2. And we're done, so we can see the algebra needed here, right? That is just going to be e to the 2x times by e to the 2x plus 30. That's going to be divided by 15 plus e to the 2x to 3 over 2. And that's part A done. So we want to determine a Maclaurin series for this. So we want to find y of 0 firstly. So plug into 0 here. X equals 0, y equals square root of 15 plus 1, which is 4. X equals 0, dy by dx equals 1 over 4. And now x equals 0, second derivative is equal to 31 over 16 to the 3 over 2, which is 64. So 31 over 64. Now using the formula for Maclaurin series, we get y equals 4 plus a quarter x plus 31 over 128 x squared and plus dot dot. Okay, so part C, we want to find this limit. So firstly, we want to find the series expansion for sine 3x. Now we know sine x is x minus x cubed over 6 plus dot dot dot. So we can write sine 3x. Just replace every x with 3x. So 3x minus 27x cubed over 6 plus dot dot dot. Okay, so we'll see these first two non-zero terms here. Okay, so that's that done. Okay, in part D, we want to use the series expansions of part A. Okay, so for part A, we have 15 plus e to the 2x is equal to this bit here. So if you minus 4, we're going to get 1/4 x plus 31 over 126 x squared plus dot dot dot. And then sine 3x we have as this. So that tells us the limit as x tends to 0, isn't it? Yep. Square root 15 plus e to the 2x minus 4 divided by sine 3x equals it's going to be 1/4 x plus 31 over 128 x squared plus dot dot dot, actually, yeah, over 3x minus 9 over 2 x cubed plus dot dot dot. Factor out x here, we get, okay, I've got the limit here, make sure you remember that. So you get limit x tends to 0, x 1/4 plus 31x of 128 plus dot 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 divided by x 3 minus 9 over 2 x squared plus dot dot dot. Can cancel them x's now, so we get limit x tends to 0, 1/4 plus 31x of 128 plus dot 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 divided by 3 minus 9 over 2. That should be x cubed here, sorry. X squared. Wait, no, it shouldn't. I'm just like x squared plus dot dot dot. Okay, so now as x tends to 0, the limit that is going to be equal to 1/4 over 1/3, which is a 12. Therefore, the limit as x tends to 0, 15 plus e to the 2x minus 4 over sine 3x equals to 12. And that's this question done. Okay. Next question, we are given a y-stress question. So we're going to let t equals tan x over 2, obviously, because that's what the question asked. And now you should know these results off the top of your head. If you don't, you can draw this triangle, okay, with angle x over 2, and then you double angle from this to find sine x. So sine x is 2t over 1 plus t squared, and dx by dt equals 2 over 1 plus t squared. So obviously differentiate this, you're going to get a half sec squared x over 2, and you just use your trig identities from there. Okay, so this tells us that dx equals 2 over 1 plus t squared dt, and now 1 plus cosec x equals 1 plus 1 over sine x equals 1 plus t squared over 2t. So that's going to be t squared plus 2t plus 1 over 2t, and that's going to be t plus 1 squared over 2t. So 1 over 1 plus cosec x is 2t over 1 plus t squared. So that means the integral dx over 1 plus cosec x is going to be the integral 2t over 1 plus t squared times by t over 1 plus t squared dt, which is the integral from 2t, wait no, I read that wrong, of 1 plus t all squared, shit, dt, and that, wait, 2 times 2 is 4, sorry, and that's what I want to show in part A. Okay, so part B, we want to do partial fractions, right? Because integrate this. So our integral, the integral from 14 over 1 plus t squared. I wrote it wrong again. Okay, so we're going to correct this. So we get 1 plus t squared, 1 plus t squared. Going to make this fraction a lot longer. Okay, so do partial fractions here. It's quite obvious what the partial fractions want to be, so I'm not going to actually do that. So we're going to get the integral from 2 over 1 plus t squared minus 2 over 1 plus t all squared dt. And now we want to evaluate both these separately, so 2 over 1 plus t squared minus dt minus integral 2 over 1 plus t all squared. So this first one is simple. It's just arctan, right? So we're going to write 2 arctan of t minus the integral from 1 plus t to the minus 2 dt. Now we can reverse chain rule this, because if we differentiate 1 plus t to the minus 1, we get minus 1 plus t to the minus 2, right? So the answer is going to be minus 2 1 plus t to the minus 1 plus t. But it is a minus in the integral, so we put a plus. Okay. Now in the question we want a k, so let's put plus k on this thing. Okay, so 2 arctan of t, right, is 2 arctan tan x over 2 plus 2 1 over tan x over 2 plus k, and that is going to be, this is going to cancel out and get x, right? Because these two cancel, they make x over 2 times 2, which is x, plus 2 1 over 1 plus tan x over 2 plus k. So from the question, a is 1 and then b is 2. And then this question done. Okay. So next question, we have L'Hopital's rule. So obviously you want 0 over 0, infinity over infinity to apply it. Part A, you're just going to apply it once. So limit as x tends to 0, 1 minus cos 7x over sine 9x. That's, as x tends to 0, we get 1 minus 1 over 0, it's x on x, 0 equals 0 over 0. So apply L'Hopital's. Okay, so differentiate this. We're going to get the limit x tends to 0, minus 7, plus 7 sine x, 7x. Over differentiate this, we get sine 9x plus x, 9x, cos 9x. So as x tends to 0, we're going to get 0 over 0 plus 0 equals 0 over 0. So L'Hopital's again. So differentiate that, we get, so we need limit x tends to 0, 49 cos 7x over 9 cos 9x. Now product rule this, so we get minus 81x. Wait, I'm bugging. Minus cos 9x minus 81 sin 9x. Yeah. Okay. So now we plug in x equals 0. Wait, it should be an 18 here, because yeah, from the second one. Okay. Plug in 0, and we're going to get 49 divided by 18 from the causes, and that's the limit proven, right? Wait, that was known pi is part I. Okay, so part I. Okay, so if you don't know Leibniz theorem, it says, so the kth derivative, dx to the k, u and v, that is going to be the sum from k, r equals 0, k choose r, dk minus r over dx to the k minus r, dr to the v over dx to the r. I should put u here, sorry. Okay, so we have u, this is u and this is v. So u, u and v, u dash is 2x, and then u dash dash equals 2, and anything further equals 0. So I'm just to go over that, and v dash is 3e to the 3x. And then so on. Okay. So that means, right, only 3 of the terms are going to be in expansion, right, because the rest goes to 0. So what we can say is dk y by dx to the k equals x squared dk by dx to the k e to the 3x plus k 2x d to the k minus 1 over dx to the k minus 1 e to the 3x plus k choose 2 d to the k minus 2 of dx to the k minus 2 e to the 3x. And now we can say dn by dx to the n of e to the 3x, because 3 to the n e to the 3x, right? So that means dky by dx to the k is going to be x squared, 3 to the k e to the 3x, using this here, plus 2kx, 3 to the k minus 1 e to the 3x, plus 2k choose 2, 3 to the k minus 2 e to the 3x. And now 2k choose 2 is going to be 2 times k minus 1 over 2. This is going to be k minus 1. So that is going to be, let me just rewrite this in a better way. 3 to the k e to the 3x x squared plus 2kx, 3 to the k minus 1 e to the 3x plus k minus 1, 3 to the k minus 2 e to the 3x. And now we can factor out a 3 to the k minus 2 e to the 3x here, because that's what we want in the question, right? And now from the first term, we're going to get 9x squared plus 6kx plus a k minus 1, which is what we wanted in the question, right? So we want d9 by y by dx to 9 equals 0. So just plug in k equals 9. So that means we get 3 to the 7 e to the 3x, 9x squared plus 54x plus 9 times 9 times 8 is 72. Okay, so 3 to the 7 e to the 3x is never equal to 0, so that tells us that 9x squared plus 54x plus 72 equals 0. We can divide everything by 9, so x squared plus 6x plus 8 equals 0. This factorizes nicely to x plus 2, x plus 4 equals 0. So that implies x equals minus 2 and x equals minus 4. And those are the x values. So that's that question done. Okay, so next question we have a reducible differential equation. So first thing we can do is do substitution as, right? So if we let x equal p to the minus 2, we can differentiate with respect to time, right? So x dot, which is dx by dt, is minus 2p to the minus 3 times p dot. But from the original, we have this, right? So p dot is going to be p 4t to the p squared minus 1 equals 4t p cubed minus p. So put that into this here, we're going to get minus 2p to the minus 3, 4t p cubed minus p. And that's going to be minus 8t plus 2p to the minus 2. And now remember, p to the minus 2 is x, so minus 8t plus 2x. So that means that x dot equals minus 8t plus 2x. So that implies dx by dt minus 2x equals minus 8t. And that's part be done. So we aim to solve this differential equation now. So we can obviously do the integrating factor, right? If we let mu of x, or mu of t, equals e to the integral minus 2t dt equals e to the minus 2t. So that implies e to the minus 2t times by dx by dt minus 2e to the minus 2tx equals minus 8t e to the minus 2t dt. No, not dt. So that tells us d by dt x e to the minus 2t equals minus 8t e to the minus 2t. So we integrate both sides, right? So that implies x e to the minus 2t equals integral minus 8t e to the minus 2t dt. Now for this, we do integral parts. So that tells us that x e to the minus 2t equals, now for this integral, we have minus integral of minus 8t e to the 2t dt. So our u is going to be t, and our dv is minus 8 to 2t, there's an liate. So that's going to be equal to 4t e to the minus 2t minus the integral of 4e to the minus 2t dt. And that is going to be equal to 4t e to the minus 2t plus 2e to the minus 2t plus c. So that implies that x is going to be equal to 4t plus 2 plus c e to the 2t. But, okay, so we want k in the question, so we let c equals k. So then 4t plus 2 plus k e to the 2t. X equals 1 over p squared, right? So that implies 1 over p squared equals 4t plus 2 plus k e to the 2t. So that implies p squared equals 1 over 4t plus 2 plus k e to the 2t, which is what we wanted to show, right? So we want to use our boundary conditions now to find p. So p equals a half and t equals 0. So p squared is a quarter. So a quarter equals 1 over 0 plus 2 plus k. So that implies 2 plus k equals 4. That implies k equals 2. So p squared equals 1 over 4t plus 2 plus 2e to the 2t. And then so that's that part done. Okay, so we want the solution. So p is just going to be the square root of this. Okay, so for part C, let's put after t equals 3, because t's in days. And then p squared, okay. So if we plug in t equals 3, p squared is going to be 1 over 4 times 3 plus 2 plus 2e to 6, right? Look at my fraction lines, are horrible. Okay, so plug this in our calculator. And we square root that, we get 0.34, 349, which is 0.034. And now they predict this, which is the same thing. Therefore, the model appears reliable, as p approximates to 0.0349, which is close to 0.034, which is what they gave us in the question, right? Okay. So next we have a question on conics. So what we want to do is just plug in the line, right? So x squared over 64 plus mx plus c over 36 equals 1 squared, sorry. So that implies, no, we're going to multiply everything by 64 times 36, which is 24 over 4. So we're going to get 36 x squared plus 64 mx plus c squared equals 23 over 4. So that implies 36 x squared plus 64 m squared x squared plus 2m cx plus c squared equals 23 over 4. So that implies 36 x squared plus 64 m squared x squared plus 128 mcx plus 64 c squared minus 23 over 4 equals 0, which is basically on the show for divide by 4 and factor out combine the coefficients. So we get 16 m squared plus 9 x squared plus 32 mcx plus 16 c squared minus 576 equals 0. So k is going to be minus 576. Okay. So it's a tangent, so we know discriminant equals to 0, right? But we're also given that 20 equals 10m plus c. So discriminant equals 0 at tangents. So what we know is 32 mc squared minus 4, 16 m squared plus 9, times by 16 c squared minus 576 equal to 0. So we're going to get 256 m squared, 16 m squared plus 9, 16 c squared minus 576 equals to 0. So that implies 256 m squared c squared minus 256 m squared c squared. We see cancellation, 144 c squared. Alright, plus 9216 m squared plus 5184 equal to 0. So that implies 9216 m squared minus 144 c squared plus 5184 equals 0. So we can divide everything by 144 to get 64 m squared minus c squared plus 36 equals to 0, right? Now we know C equals 10 minus 20m from this equation up here. From this up here, right? So that tells us that 20 minus 10m squared equals 64m squared minus 36, plus 36, sorry. So 400 minus 400m plus 100m squared equals 64m squared plus 36. So that's going to tell us 36m squared minus 400m plus 364 equals 0. Divided by 4, we get 9m squared minus 100m plus 91 equals 0. Now this factorizes into 9m minus 91, m minus 91 equals 0. So m equals 91 by 9, or 1. So we want to plug in to C. So if m equals 1, y equals x plus 10. Now if m equals 91 over 9, C is going to be minus 730 over 9. So the two lines possible are going to be y equals x plus 10 and y equals 91 over 9, x minus 730 over 9. And those are both the lines, right? Okay, so on to the final question, which is... Okay, so we're on the last question of the paper now. And we're going to find the area, so we can use cross product. So the area is going to be the magnitude of EF cross EH, right? So EF is going to be OF minus OE, sorry. So we get 7 minus 2, 7, minus 10, minus 1, minus 6. It's going to be minus 3, minus 1, and 13. And then EH is OH minus OE, which is going to be 13, 3 minus 4, minus 10, minus 1, minus 6, which is 3, 4, 2. So now EF cross EH is determined IJK, minus 3, 1, 13, 3, 4, 2. And that is going to give us minus 54I plus 45J, because don't remember the sign changes, and then minus 9K. So we want the magnitude of this, which is going to be, we have to find the magnitude, right? Which is because 9 root 62, and that's the magnitude. So that's part A done. Now for part B, what we can do is use the fact that L passes through E, right? And it's perpendicular to this. So that the normal vector is the cross product, which is what we got from part A, right? So we can simplify by dividing by minus 9. I mean, you don't have to do this, but it's just saying good. So what we can use then is R minus 6 minus 5, 1, which is dividing that vector by 9. Wait, no, sorry. It's R minus E, because that's, yeah. So cross 6 minus 5, 1 equals 0, and that's part B done. Now for part C, the volume is going to be the base area times the perpendicular height, right? And now in part A, we found the base area already, so what we need to do is find the perpendicular height. So we have the normal vector, so we can write the plane. So we have 6x minus 5y plus z equals d for some d. Now we substitute point E in to find d. So we're going to get 60 minus 5, no, plus 5 minus 6 equals d, which is 59. Okay, so the opposite face is in parallel, right? So what we can say is it has the same normal vector, but has a different point, which is this point here in the question. So what we do is we put 6, 25, minus 5, minus 4, plus 13 equals d. So that tells us that d is 183. So now to find the distance between them, we do the magnitude of the normal vector, not the equation of the plane, sorry, minus both d's, right? So 183 minus 59 is 124. And then the magnitude of the normal vector is root 62. So that means the volume is going to be 9 root 62 times 124 root 62. And now the root 62's cancel, which is nice. Let me just get 1116 because these cancel. And that is our final answer. And that's the end of the paper. So hopefully this helped. If you need a tutor, make sure tutor.com. You can get a high quality tutor and university tutor for any of your subjects.